Good afternoon, pilot teachers, and good afternoon, students. Thank you. Sit down. Okay, today we're going to look at the second last of those features that are to do with what contributes or what makes temperatures different from one place to another. And today we are going to look at aspect, and I'm going to explain a little bit more on what aspect is and how it influences or it has an influence on temperature. Before we go ahead to looking at aspect and how it has an influence on temperature, let us look at what we have covered so far from those different features and factors which contributes to variation in temperature. And in our last lesson, we looked at cloud cover as well as their distance from the sea. Okay, looking at cloud cover now, a very good explanation was given on how cloud cover can affect temperature. Generally, we looked at two different areas, and we had the equatorial region by day, the equatorial region by night, and also we had the desert region by day and the desert area or region by night. Looking at the equatorial region, first of all, incoming solar radiation is actually checked by the clouds that are found and also formed in those areas. Therefore, not all the radiation comes through to the surface. Certain percentage is reflected back. At the same time, whatever is already on the surface to heat up the surface as insolation does not all escape during the day as well, because the clouds do act like a blanket to prevent the loss of the heat on the Earth's surface. By night, note whatever radiation that has already reached the surface as insolation. If there are clouds, not all of it escapes, because the clouds therefore act as a blanket again to prevent the excessive loss. Therefore, by night, if there are clouds, the temperatures tend to be warmer or hotter. Then we looked at an area of the world whereby there are hardly any cloud cover or any clouds, and that is the desert region. By day, because of the absence of clouds, we have maximum solar radiation reaching the surface, resulting in the areas then becoming very hot. That's in the desert region. By night, again, because of the absence of clouds, the heat is able to escape freely, resulting then in the desert regions being very cold or cold during the night or at night. And because of cloud cover, we also can see the difference in the temperatures. The second feature that we have also covered, or factor that we have covered, is that of ocean currents. A basic rule that you were supposed to remember was that generally currents that flow from the equator towards the tropics, equator towards the poles, they are supposed to be warm currents. Any ocean currents that flow from the poles towards the equator are cold currents. Okay, and that information, we had a simple diagram to illustrate that. And the colors, perhaps red pen that you would have used, should show from the equator towards the poles, demonstrating the warm currents, and a blue pen perhaps from the poles, pointing towards the equator to demonstrate or to show the flow of the cold currents. We had a list, or you were supposed to actually make a list of the main ocean currents, and as well as that, you were supposed to put those different ocean currents in the correct heading under whether they are warm currents or cold currents. Looking at what you should have completed also for your homework, you can double check now. The cold currents, first of all, you should have the Labrador current, East Greenland current, the Canaries, Kamchatka, Californian current, West Australian current, the Benguela current, and west wind drift. Those are some examples that we were able to list from the monitor and also from the atlas. Are there any other currents that we did not include yesterday that we can make note of them also today under cold currents? Any others that you were supposed to look up and perhaps you were able to find for your homework? Any others? Yes, okay. Can we look at those ones that you have already listed as part of your homework under cold currents? Gideon will give us what you have got The rest of us, we double check. Again, you had to check from the other sources and maybe the other atlases that might have contained that information.
The Peru drift or current.
Okay, the Peru current, correct. You'll find that in south, next to or adjacent to South American continent. The Peru current, we'll put that together with the cold current. Any other currents which are cold currents you have found, beside the ones listed and now Peru current also given? Val, any others from the class? You were only able to find the Peru current? Elsie? Elsie?
The East Greenland current.
The East Greenland current, it's already given there.
Okay. The Oya-Siwa current.
The Oya-Siwa current, good. In Japan, we have two currents there. The warm current is the Kuro-Siwo current. The Oya-Siwa current then becomes the cold current. Okay, that's supposed to be also included. Any others? Kiran?
The Falkland.
The Falkland currents, okay, good. South America, again, the continent, we're looking at the adjacent to that continent. The Falkland current is also an example of a cold current. So at least we have about 3 already given. Any others? Okay, Gideon, any other cold currents beside the 3 given?
The Arctic Circle current.
The Arctic Circle current, okay, the current, cold current flowing where the Arctic Circle is or the Arctic region is, correct? That's in the northern hemisphere. Any other cold currents? Okay, if there are none, then we move on to the warm currents. What we have listed in our last lesson, quickly double check. North Atlantic Drift is a warm current. The Gulf Stream is a warm current. North Equatorial Current, the South Equatorial Current, Brazilian Current, Mozambique Current, the Kuro-Siwo Current, and the East Australian Current. Those were from the map we had on the monitor. Any others that you're supposed to find also for your homework? Val, any others to be included? No? Ovio?
The North Pacific current.
The North Pacific Current, correct? Yes. Bill?
The Norwegian current.
Norwegian Current, correct? Elsie?
The Guinea current.
The Guinea Current, correct? And Christopher?
The Agulhas current.
The
Agulhas. Agulhas
The
current.
Agulhas Current. Can you tell us maybe which continent or which region we are able to find the Agulhas Current?
Africa.
In Africa, okay. Gideon?
East Australian current.
East Australian Current, already given. Okay, we double check, yes. Definitely East Australian is correct, but it's already given on our map that we had yesterday or in our last lesson. Okay, we'll move on. At least we were able to list other examples beside the ones that were on our monitor. Okay, today we are going to move on to looking at the second last of the factors which contribute to what makes temperature different, and that is to do with aspect. A definition to what aspect is, it is to do with the direction in which a slope faces, especially in the context of exposure or different degrees of insolation. Looking at the maybe more information from our booklet, we are going to find aspect as factor number 3 or C, and the information presented in our booklet will be what we will use as the base for our introduction to that particular factor and how that factor affects temperature or how it contributes to making temperature different from one place to another. So I'd like you now to make reference to your booklet, and we'll go through the information from the booklet, and as well as that I'll further explain aspect and its impact on temperature. Okay, looking at the booklet, aspect basically or simply refers to the slope of the land. Aspect also determines the angle at which the sun's rays strike the earth. For example, the slopes of hills or mountains in the tropics do not receive the sun's rays vertically when the sun is directly overhead. So, temperatures are cooler on the slopes than on level plateaus at the same elevation. That point is important. At the tropics, we note that the sun's rays does not actually hit the mountains vertically. Rather, it hits the mountains at an angle. Meanwhile, if we have a plateau, which is a flat piece of elevated highland area, the sun's rays will actually hit that area vertically, or it will be directly exposed. Whereas a hill, if we look at perhaps a simple diagram to illustrate that, we have a plateau, a flat elevated area, whereas a hill or a mountain, whereby you have the surface area a little bit smaller in comparison to the plateau. So if we have a plateau here, a hill or mountain. We're looking at the tropical region. The sun, rays of the sun perhaps will heat up that flat area, resulting in this area being more hotter in comparison to at the same height, and the sun here perhaps hitting at an angle. The areas that get to be exposed will be much more hotter compared to those areas that are not directly exposed. That is what we are looking at in terms of aspect. This might be in the tropical region. So the plateaus, because they have a flatter area, their tops might be quicker in terms of heating up compared to the hills or the mountains, because the area is a little bit smaller. The angle of the sun coming, or the sun's rays coming at an angle, and not all the areas get to be heated as in comparison to that of a plateau. That is what the statement in our book is making reference to. Okay, this time we move on. Conversely, in the higher latitudes, that means now moving away from the tropics, slopes facing the sun receive the rays more vertically than do the plains, and thus are warmer. So in the temperate latitudes or the higher latitudes, we already know that the sun's rays does not come vertically towards those areas. Rather, it comes at an angle. So therefore, those slopes that are facing the sun, and when the sun's heat comes towards them directly, they get to be warmer compared to the slope which is not facing the sun directly. Therefore, the slopes that are facing the sun tend to be warmer compared to those that are not facing the sun. And that's what we make reference to when we talk about aspect. Okay, aspect is more common in the temperate latitudes. Therefore, we are going to look at the diagram given on figure 9, and that diagram is actually illustrating a slope in a temperate latitude or a higher latitude. If you look at the diagram given, you will note that the information given at the bottom of the diagram, figure 9, tells us that north of the Tropic of Cancer, south-facing slopes are sunnier and warmer than the north-facing slope. So this particular mountain here that is shown is a mountain in the northern hemisphere. And because it is in the northern hemisphere, and one side of the mountain is actually facing the north direction, and the other side of the mountain is in the south direction. And because this mountain is in the northern hemisphere, the south slope of that mountain will receive the sun's rays more than the northern slope of that mountain. Therefore, this mountain in the northern hemisphere will have the southern slope of it hotter compared to the northern slope of that mountain. We understand that? Okay, if we go to the southern hemisphere, we will look at, in the southern hemisphere this time, a mountain which is in the southern hemisphere, the northern part and the southern part of it. Because it is in the southern hemisphere, the slopes northern side will receive more sunlight compared to that mountain's southern slope, because the northern slope will be facing the direct sunlight, so it will be warmer compared to its southern slope. This time I'm looking at a mountain in the southern hemisphere. And when we are making reference to the slope of a hill or a mountain getting hotter compared to the other part of it, then we are making reference to aspect. Let's look at a diagram maybe to help us. This diagram here, this is actually showing a mountain in the northern hemisphere. If I have to separate these two diagrams here, I would have drawn in the equator. Okay? If I drew in the equator here, maybe that might help to separate those two diagrams. Okay? The equator, northern hemisphere, southern hemisphere. Let me perhaps put the diagram on the board. This is for the temperate region. Okay, let's look at this diagram. Here, this diagram here is showing us the mountains perhaps in the northern hemisphere on this side, and this one here, the southern hemisphere. We have the equator to the north, to the south. This is going towards the North Pole, the arrow here going towards the South Pole. Okay, the sun. Remember, when the sun is actually moving towards the north, the furthest point it will go to will be the Tropic of Cancer, which is 23.5 degrees. So here is a mountain which is in the northern hemisphere. The southern slope of it will be the side which is facing towards the, or closest to the equator. Meanwhile, the northern slope of the mountain is going to be the one that is towards the North Pole. I'm in the northern hemisphere. The equator here separates that. We understand the direction so far. Okay, the reason for why this is south is because towards the North Pole, this slope here is facing north, and this slope here is facing towards the south. Okay, I'm in the northern hemisphere. The sun directly above 23.5 degrees. Because it's directly above 23.5 degrees, the south-facing slope will get more sunlight compared to the north-facing slope. So we're looking at more of the sunlight in the northern hemisphere mountain, warming up the south-facing slope compared to the north-facing slope. We understand this? Okay, now we come to the southern hemisphere. Here's the equator separating the the northern hemisphere from the southern hemisphere. We have a mountain here, which is in the southern hemisphere. The areas going towards the south pole will be the north, and the areas coming towards the equator will be the south. No, should be the other way around, sorry. Yep. We have the areas going towards the south pole should be in the south, and the areas coming towards the equator should be the north. Okay, the first diagram, no problem. We're looking at the second diagram. Okay, the reason why we are having north here is because we are looking at the north pole on our left side and the south pole on our right side. So the further we go in the right direction, we are going south, and the further we go in the left direction, we are going north. Okay, in the southern hemisphere now, we have a mountain, of which a mountain is actually standing. It has its one slope facing the north, the other slope facing the south. The sun at its highest point will be at 23.5 degrees, which is the Tropic of Cancer. Okay, not Cancer, sorry, the Tropic of Capricorn in the southern hemisphere. Because the sun will be directly above at 23.5 degrees, the Tropic of Capricorn, the north-facing slopes in the southern hemisphere will receive more sun's energy compared to the south-facing slope in the southern hemisphere. So in the southern hemisphere, the north-facing slopes will be warmer compared to the south-facing slopes in the southern hemisphere. In the northern hemisphere, it will be different, or the opposite. It is the south-facing slope in the northern hemisphere which will be warmer compared to the north-facing slope in the northern hemisphere. Okay, if we're looking at the diagram on the monitor, that is showing us the same thing. Here we have in the northern hemisphere, the south-facing slope, intensity of the radiation of the sun is greater, a smaller area to heat up, it will be warmer, a lot more heating on this side here, the south-facing slope, compared to the north-facing slope. The angle of the sun needs to heat up a larger area, less intensity, temperatures will be less compared to the south-facing slope. In the southern hemisphere, it is the north-facing slope that will receive a lot more or direct energy from the sun, the vertical rays of the sun coming through, smaller area to heat up. The northern slope will be hotter compared to the southern slope, where the angle of the sun is a little bit, the angle is not as great as the direct vertical angle on the northern slope. Therefore, it will be cooler on the south side of the south-facing slopes compared to the northern side of the mountains in the southern hemisphere. Does that make sense, or do we need a little bit more explanation? Make sense? Okay, anyone with any maybe immediate question with regard to aspect? No questions? I'll give you 5 minutes. And the 5 minutes that I'm going to give you will be for your note-taking. And not only that, perhaps the diagram here to explain the mountains, especially in the temperate regions, and which parts of the mountains get to be warmer, especially when we're looking at the north and the south. And note also, we are concentrating mainly on those mountains that sit in such a way that their one slope of the mountain is facing the north and the other slope is facing the south in those different hemispheres. And when we're referring to those mountains, then aspect becomes common in them. Not so much of those mountains that do not have their slopes facing in those directions. It's mainly for those mountains whose slopes are facing north and facing south in those two hemispheres. Okay, 5 minutes then for your note-taking. You can make reference to the booklet for information also to copy down, and then we'll go ahead with some examples of aspect. Maybe put the equator through there and it might help us so that you'll know northern hemisphere, southern hemisphere. Mm-hmm. Because remember I told you that the mountains will have to be facing in the direction that the northern part is facing
The pole.
yeah, towards the poles, and the southern parts facing towards the southern hemisphere. Okay, and then that will be possible. But if you have a diagram like this, obviously you are correct also. You see, you can have, like in the northern hemisphere, it will be the south, because the north will be the other side of the mountain. Can you see that? And here, it's the north that will be hit. The south is the side here that's not it. So you can have a diagram exactly like that also. And then you can say this is the side which is facing where the sun will be directly, it's the southern slope, because the other side is the northern slope. Similarly, this is the side that is the southern slope. The northern slope will be the one that will be directly in line with the sun. So yes, you can have a diagram like that. That's still correct, as long as you are able to explain. I put it in that manner so that it will help with the north and the south. Okay, do we all have our diagrams and no taking down on aspect? Okay, if you look up on the board, as I was walking around, a student asked, couldn't we have our diagram drawn in this manner? And the answer is yes, we can have our diagram drawn in this manner also. But this we have to understand that if the equator is here, this slope here that is facing the equator is the south slope. Meanwhile, on the other side will be the north slope. Again, we can say the south-facing slope in the northern hemisphere will be exposed more to the sun's energy compared to the north-facing slope. That's why I've colored in this side here. We're following. Okay, meanwhile in the southern hemisphere, I have not colored this part in because this is the side which is the southern slope and it is facing away from the sun. It will be the other side of this diagram here, the north-facing slope, that should be getting exposure, and therefore it will be heated more than the southern side. So I've shaded in this area here for the top diagram because that is where the southern slope gets most of the solar radiation because it's on the side facing the sun, whereas the other slope also it is in sunlight, but the intensity of the heat is not going to be as great as on the south slope. Here, the south slope is away from the sun. The north slope will be the one that should be colored, and that's what will be taking a lot more heat compared to the south slope, so it will be hotter. And so when we look at the degree of exposure in terms of solar radiation to the slope of the land, then we are looking at aspect. And aspect definitely also has an influence on variation in temperature because one side of the mountain gets to be hotter than the other side because of the way in which the natural feature is constructed or built, especially the mountains and the hills. Let's look at some examples in reality that we can see about aspect. Okay, if you're looking at this particular photograph, perhaps taken in the Arctic region, North Pole, South Pole, but you can see here, can you see this path where they are exposed to the sun's heat more compared to the area that is in shadow? So in reality, these areas here will be hotter in terms of their temperature compared to this section here. This is a good picture, perhaps showing us what we mean by aspect. The same day, more of the heat concentrating on this slope here. If it is in the northern hemisphere, then this will be the south-facing slope, getting more heat compared to the north-facing slope, whereby it is in shadow. Here is another good example. Perhaps when we look at our cities or towns, we can see aspect also. When we look at certain parts of the city get to be heated up or lighted, and the other parts are in shadow. Can you see that? These sections here in shadow, this area here heated up or lighted. Perhaps sometimes also we're walking around and we're looking around in Port Moresby and that mountain down at, or not mountain, sorry, but the hill down at Kila Kila. You will also note that sometimes certain sections of it are actually in shadow. Meanwhile, certain sections of it are heated up or the light is directly on it. Temperatures can actually vary if we're looking at more intensity in one part of it compared to the other part. Buildings throughout the world and people who are also responsible for construction of homes, especially in the temperate regions, should be concerned with regard to aspect, because when you are constructing your homes and putting up buildings, you would like to ensure that there is enough light that should be able to reach all the different buildings. And you don't want to build them too close together, because if you do build them close together, you might find that there are certain places that perhaps direct sunlight might not be able to get to the people who are living there. So the distance between one building and the other building has to cater for the angle of the midday sun especially. And this is also important for architecture, the builders. So we don't put the homes too close together that only one home is actually receiving sunlight and the others are not able to receive that amount of sunlight. Within the temperate region, note the angle of the sun is a little bit more wider. Therefore, the spacing between one building to the other has to be considered if we are also trying to look at ensuring that there is enough maybe light and heat energy going through all the different buildings. In the maybe tropical regions, the angle of the sun is not so much of a problem because the sun is usually directly overhead. So the distance between the buildings does not have to be that great as in comparison to the temperate regions. Okay, so here we're looking at the angle of the midday sun is a little bit more vertical as in comparison to here where it's greater. So the distance here between those two buildings are bigger or wider compared to perhaps at the lower latitudes or the tropical regions. So when we're talking about building and architecture also, you don't just go up and put up the buildings. These are some of the things that you need to consider when you are putting up buildings. Okay, that will also bring us to the end of our lesson today. Class, if you can now stand up. To the pilot teachers, our keyword for lesson 108 is aspect. Good afternoon and thank you, students.